Good morning, Tahmeena Khan is here with video number 6 on hypothesis testing. It is a topic from S2 A-Level Mathematics CAIE syllabus. And the two questions I will cover in this video will be regarding or related to confidence interval, and I will also make use of approximate normal. The actual case will be of binomial proportion, and we will use approximate normal using z-test to find out the result of the hypothesis test. So before I begin, you can see the blog address of my videos. All the links of my videos I have made so far is up there. So for your quick reference, you can go, and then it's a very user-friendly website. Blog. You can easily see the videos, whatever you're looking for. So let's start. So this question I have taken from November 18, variant 7 to question 6. So in this question it says that Angus found that the train was late on 15% of his daily journey to work. So basically the proportion of train coming late is 15%, and following a timetable change, Angus found that out of 60 randomly chosen days, his train was late on 6 days. Now we have to do 10% significance level, at 10% significance level, a test, and then we have to find out that either train are late less often than it was before the timetable change. So this is part 1. Let's do part 1. So first of all, significance level, hypothesis testing. And then we will read the rest of the question. So according to the question right now, the null hypothesis is 0.15. Binomial proportion is 0.15. And because we have to say either after the change in timetable, the train is late less often, so that's why the symbol less will come here. And it is at 10%, so because of this symbol, I know it is lower tail, and it is on this side accordingly. So I have to find out now the at the test value, which is given 6 days, it was seen that train was late. So on those basis I will see either the result come in the critical region or not. Okay, so I'm using here approximate normal. We know when we change binomial distribution case into normal and we are using approximate normal case, the distribution is NP and NPQ, and condition is that NP is greater than 5 and NQ is greater than 5. So N was 60, P was 0.15. So result is 9, and here it is 51. So both results are greater than 5, so we can use normal approximation. And NPQ is 7.65. So the values will be 9, 7.65, mu and variance. This is all from S1 basically. It is last year work if you remember. And the value of z will be x minus np divided by root npq, if you remember this thing. I'll just explain what I have written here in a while. Okay, so the test value was 6. So we have to calculate the probability for x less than equals to 6. And because it is a discrete variable and normal is continuous variable, so we will use continuity correction. Now if it is less than equals to 6, it means, if I just try to explain to you with the help of number line, I'm talking about the values which are on the left side of 6. So either you add 0.5 or subtract 0.5. That is what you have to decide. So if I add 0.5, it will come here, and going from here to the left will include 6. But if I subtract 0.5 from 6, it will be 5.5, and the values I will take will go from here, and these values will not include 6, and 6 is equals to, because 6 is included, right? It was a test value which is always included. So that's why I have to take it from 6.5, and that is the reason I have taken 6 plus 0.5. So now after that I am changing this x into z using this formula. So x is this value, mu is this value, and standard deviation is root of this variance. After that, I got the z value, and then I will check, do I need to calculate probability? I don't need to, because at 10% the z value is minus 1.282 and 0.9038. Do you think it is here or here? Yes, it is here. According to the number line, 0.9038 is bigger than this number, so it will come on this side. It means the value is not in the critical region, and therefore you cannot reject H0. And if you cannot reject H0, it simply means that there is no evidence that train is late less often. Is it okay? Now, one thing I would like to clear here. In the question, it was not said that use suitable approximation. So I just used it myself. Otherwise, if I will use binomial formula, which is NCR, PR, QN minus R, then I would have to do it on 6, 5, 4, 3, 2, 1, 0. Right? Which needs a lot of time to do work. If you want to do by that method, you can. It's fine. You will get the same result. But using this approximate when condition is met, so I just use this, right? Let's do the next part now. Now this part of the question is saying that find out the confidence interval for the proportion, and confidence interval is represented by alpha when the upper limit of the interval is 0.150, and you have to tell the confidence interval correct to the nearest integer. So if question is clear, it's fine. If not, let me explain to you with the help of the sketch. So basically, in short, you have to find confidence interval for the population proportion, and upper limit of the confidence interval is given to you. Okay, so this is the meaning of the question. Confidence interval mean here, and this limit is given to you. Now if you remember, in chapter 9, I have explained to you the formula for the confidence interval for population proportion. This distance from the mean is represented by z root PS QS over n, and the formula for the confidence interval for population proportion is this: PS plus minus z root PS QS over n. PS is your this value which is in the middle, mean, and plus value mean this side you add, minus value mean this side you subtract. Now in the question, the upper limit of the confidence interval is given. It means I can write this plus this is equals to upper limit, and lower limit will be, in case if it is given, I'm just giving you extra information here, then it will be subtracted. So now coming back, in the question the upper limit is given to you 0.150, so you can substitute it, equating it equals to plus z root PS QS over 16. Now we have to find out z, and PS is given to us. How? 60 was the sample, and 6 days it was turned out that train was late. So 6 over 60 is equals to 0.1, which is our PS. So once you know P, you know your Q also, right? So now using simple algebra, you will calculate your value of Z. So here we have done little more calculation, just one more step. So Z is coming 1.291. So it means the upper value which was given to you, the Z value over there is 1.291. So now you will read the Z table, because Z table always give you the probability of the left hand side of Z. So I will read the Z value against this, and I will get this whole probability. So before showing you the solution, I'm just explaining you what I will do now. Now this inner portion is my confidence interval, right? And we know that from mean on each side it is 50% probability. It's mean 0.5 here, 0.5 here. So if from Z table I get this whole probability and minus 0.5 from it, because 0.5 is from here. I'm repeating, the proportion I will get, or the probability I will get against this Z value, it will be from here till here. and I will minus 0.5 from here to get this. And then I will just double it because these two are equal. It is symmetrical. So same thing I'm doing. I'm writing the z value against 1.291 and it is coming 0.9017. It means this whole thing is 0.9017. From this I will minus 0.5. So I got 0.4017, which is this portion, and then I will double it. Here it is 0.8034 because question was saying give your answer to the nearest integer. So you can say to the nearest integer alpha is 80%. So confidence interval is 80%. Now let's see another question. It was also from Cambridge. I'll tell you which year. Now I don't know the year of this question because I have picked it up from one of the statistics book by Croshaw and Chamber. So year was not written, but it is written C, so it is from past paper basically. Anyway, so this question is talking about the cars arriving at T junction. They are coming from left and right. Okay, I can show you the question here. They're coming from left and right, and cars are equally likely to turn right or left, and cars are more likely to turn right than left. So if you see here, question is saying decide between the following alternative. So it is not told to you, but you have to write your null hypothesis and alternative hypothesis, and that is the first question also. And second part of the question is saying that if the sample size is of 40 cars, then what is the least number of cars for which you will reject the null hypothesis if the significance level is 2%. And then last part is saying find out the type 2 error when the new value is 0.80 is given to you. So let's start with the first part, which is saying find the suitable null and alternative hypothesis, which is very much clear from these two lines, right? So let's see here. Like I told you the 7 steps, so I'm just explaining again. First step is to define the random variable. So let x be the number of cars in 40 that turns right. Now because it was given in the question that cars more likely to turn right, so we are taking it as our alternative hypothesis. So random variable is around car turning right when x is equals to b 40 comma p. So your null hypothesis will be p equals to 0.5 and alternative hypothesis p greater than 0.5. And now we will find out the least number of cars for which we can reject h naught. Okay, so according to diagram, 2% will be on the right hand side because it was written here more likely to turn right, red cars, right? Oh sorry, cars. So according to null hypothesis, if it is true, then your distribution will be 40 comma 0.5. And for suitable approximation, now why we are doing suitable approximation? I'll just explain you in a while. Let's see the conditions. Though I have already explained to you in the previous question, but we will see it here again. Okay, so whenever you use suitable approximation, you always check the condition. You have to show to the examiner that yes, conditions are met, and that's why I can use suitable approximation. So right now I'm checking for normal approximation. The condition is NP should be greater than 5 and NQ should be greater than 5. This is my N and P. So I'm using N and P, and I'm sure you remember what is Q. Q is 1 minus P. In this case P is 0.5, so Q will also be 0.5. So both the answers are greater than 5, so I can use normal approximation. And the distribution for normal approximation will be NP comma NPQ, which is 20 comma 10, because when you will multiply N by P by Q, you will get 10. Okay, so now use a one-tail test. Why a one-tail test upper tail? Because red cars are more likely to turn to the right and at 2% significance level. So we will reject H naught if the values of n are more than this and they are less than 2%, because question says at least n car. Whenever the question says at least, it means the value and more than that. Just imagine if I say you should have at least 5 rupees. What does it mean? Either 5 rupees or more than 5 rupees, right? So when question says the least number of car, it means x greater than equals to n such that those values give you less than 2%. Now the thing here, if you do not use normal approximation, how many values you will try when the total numbers are 40? So it will become very tedious. That's why we have used normal approximation. Okay. Now the question here is, this is binomial proportion and you are using normal approximation. The point here is you are going from discrete variable to continuous variable. It means you have to add or subtract 0.5 in n. Now see here on the number line, because main confusion to a student is either they will add 0.5 or they will subtract 0.5. Now suppose n is here, it is representing any number, right? You have to go to the right side because it is saying greater than or equals to. Now if you add 0.5, the number will be on the right hand side, because we know on the number line right hand side numbers are bigger. So if you add 0.5 in it, it will be some number here, and from here you will go on the right. But if you subtract 0.5, it will be on this side, and when you will go on the right from here, n will be included. Whereas if you go from here, n will not be included. And according to this, n has to be included. So that's why we will subtract 0.5. I hope it makes sense to you. So with the continuity correction, it will become probability of x greater than n minus 0.5 less than 2%, right? Okay, so after that I'm changing x into z using this formula, x minus np root npq. So this was my x. I just showed you I subtracted 0.5y minus np root npq less than 0.02. Now from the table, I am checking. Now let me explain to you on this sketch what do I mean. Okay, which value of z will have probability less than 2%. Now 2% less than is on this side, right? And it is saying z greater than. So this is a number, and on the right side of that number the area is less than 2%. It means the diagram is like this. Make sense? Forget about this number for the time being. Just look at this area, 0.2%. When you read z table, it always read the probability of the left hand side. So to read this value, I need to know this probability. If it is 2% here, then it is 98% here. And that's why from the table I will read z value against the probability 0.98. And from there I got 2.055. It means this whole thing is equals to 2.055. And that's why I have written here, okay, if z is greater than 2.055, then this will be equals to 2%, right? Now z is actually this, because we have to find out n. So now I can say the value of this thing is greater than 2.055, which is here, because I'm talking about these values greater than this side. So greater than 2.055. Okay, so which is giving me n greater than 26.998. n is my integer, it's representing number of cars. So the next integer after 26.9 is 27. Do not think that I'm rounding it off, because here students make mistake. If answer is 26.3, even then I will take 27, because I have to take the next integer value. Okay. So you will reject h0 if x is greater than or equals to 27. So you have found your n value, and this is what question was saying, to find out at least the value at which the probability is less than 2%. So now you found your rejection criteria if x is greater than equals to 27. Now next part was saying find out the type 2 error when your actual value of the alternate hypothesis is 0.8. This was given to you in the question. Now we know probability of type 2 error mean except H0. So if you are rejecting H0 at this, you will accept it at x less than 27. It will be reverse of it, because if this side you are rejecting, this side you will accept it. So for type 2 error, you accept H0. So I will take probability of x less than 27. So I have explained you that part here. When I will show you after this, I hope you will understand. So this is the probability distribution, binomial distribution, and I will use this. Now again I am using normal approximation, so I am checking the condition because now I have new alternative hypothesis. So both answers are greater than 5. Same conditions, right? So I can use normal approximation. And you can see I'm substituting the value from here. NPQ, I did not show you calculation here, but you can do it. It will be 40 into 0.8 into 0.2 and you will get it. And now, exactly what I have just explained to you. Type 2 error mean except H0. And because in the previous part we were rejecting for x greater than equals to 37, so at less than 27 I will accept it. Now again the continuity correction you have to apply. Now with the help of number line, if this is 27 and you have to take left hand side, it is saying less than. Now you see equals to symbol is not here, so it means this is not included. So if you add 0.5 in it, it means number will come somewhere here, and if you go from here on the left, 27 will be included. I don't want to include it because there is no equals to. So I will subtract 0.5 from it so that the value of this side will go left and 27 will not be included. So that's why we are taking 26.5, right? And now I'm just showing you the step we write the probability of x less than 26.5 when the distribution of normal approximation is this. So now changing x into z, which is x minus mu, np and root npq, and I found the value of z, which is minus 2.174. I have to calculate this probability, and I hope you remember from S1 that we use symmetrical method, and it is 1 minus probability of z less than 2.174, which is giving me the answer of 1.5%. So this is the probability of type 2 error. With this I will finish this video. I hope you understood. In the next video now I will come up with more new concepts we have not checked yet. So far we have done almost 80% of the ways the hypothesis question is asked. Thank you very much for watching this video. If you have learned anything, if it was helping you to develop some better understanding, I would like you to press like and subscribe button. See you in the next video. Have a good day. Bye bye. Allah Hafiz.